Hi, today we are going to multiply and simplify radical expressions. This is Mrs. Slater, and here we go. General formula for multiplying radical expressions looks something like this. If you had two radicals, A and B, with the exact same index, that's very important to have the same index, you can combine them all into one under the same radical sign. So for example, if you had the square root of 9 and the square root of 4, you can combine them to be square root of 36, which gives you 6. Okay, you can also do the reverse. If you have k and then 3 different things under the variable, you can split them all to be individual problems. And again, if they're all the same index, this is allowed. All right, so let's go on to some examples. Here we have 19 times 7. Go ahead and push pause and get your calculator out. Okay, and then when you multiply those together, you should get 133, and that would be the most simplified answer. Here, on the next one, if we multiply these together, x plus 2y and x minus 2y give us an answer of x squared minus 4y squared. And we are going to have to simplify it just by that as our final answer, and there's nothing else we can do with that. So please stop at that moment. Again, when you know when to stop is if you have that plus or minus sign, and nothing is going to factor take the square root of anything nicely. Okay, the next one we have is multiplying 403 and 7 together. So since they're the same index, when you multiply those together, you get 2,821. And then the last one, throw in some cube roots. If we multiply them together, it'd be 8x times x to the 4th plus 5 for a final simplified answer of 8x to the 5th plus 40x. Push pause and read the following sentence. And now let's begin. If you have 8 in your radical sign, you want to look for any of these numbers that could be factors of 8. Well, I know for sure that 4 goes into 8. So I'm going to split this up into what is a perfect square and what's not a perfect square. As long as those multiply together to give you 8, that is okay. And as long as this one is something that we can break down, because we know square root of 4 is 2. And when you simplify it, you end up with 2 square root of 2 as your answer. And that is called simplified radical form. Okay, 18, if you look at your list again, what is a perfect square that goes into 18? And the only thing on the list that I can see here is a 9. 9 would go in the first one. 2 multiplies together to give you 18, which leaves you with an answer of 3 radical 2. Simplified radical form. Okay, the next one has a little twist just because it has an x to the 4th. Okay, let's just look at splitting it up again into two parts. 24 has a factor of 4 that goes into it, so I'm going to use 4 and 6. So basically I just ignore the x's for just a moment. Okay, I also know that x to the 4th is an even number, so the fact that there is a square root out here, that means it's going to all break down. Okay, so I'm splitting it into what will be a perfect square and what would not. So that's going to be where the square root of 6 is going to be. So the square root of 4 is 2. The square root of x to the 4th, you would just divide those two, because 4 divided by 2 is 2. And the square root of 6 is going to be left in your answer. Let's move on to the next one, which is 12a squared b to the 4th. Again, we're splitting it up into 2 because multiplication allows us to do that. 12, the only number that goes into 12 that's in our list is 4, and 3 would be our leftover. A squared is an even number, so that's going to go on the left radical. B to the 4th is also it's even number, but c to the 5th, this is the first time we've ever had to split it. So 4 of those c's will actually break down, but that leftover we're going to put in the second radical. Now, when we simplify, we know that the radical square root of 4 is 2. 2 divided by 2 is 1. 4 divided by 2 is 2, and 4 divided by 2 is 2. And 3c is what's going to have to be left over that we cannot simplify. Now, this answer right here is missing something, and it goes back to what we talked about in 7.1, where when do you need an absolute value? So if you notice, I can't guarantee that that a is going to be a perfect square, a positive number, so I'm going to put absolute value signs around that. The other ones, anything squared, it's going to give me a positive number, so I don't have to worry about it. Final answer, have to have the absolute value around the a. All right, so this one right here, 144 is actually the next one on the list. Square root of 144 is 12. So all of this number, 144, is going to go in here. Again, it's squared. So only 2 of them will fit inside of here. And I'm just going to give myself a little more room. B to the 6, all of them will fit. I'm sorry, I forgot the A, because I have to have a total of 3 A's. B to the 6, and only 6 of those, leaving us with 1 left over. Okay, so let's solve. Square root of 144 is 12. 2 divided by 2 is 1. 6 divided by 2 is 3. And 6 divided by 2, again, is 3. Leaving us with square root of AC for the leftovers. Now, do we need absolute values? Yes, we do, because it's a squared term. Any even index, we're going to need absolute values. And in this case, you have a to the first. We can't guarantee that's going to be positive, and we can't guarantee b to the cubed and c cubed. So all of those are going to have to go in the absolute value sign. Okay, push pause and read the sentence. Now that you've read it, we have got to look for our list of perfect cubes. Again, we talked about this yesterday, but the cube root of 1 is 1. Cube root of 8 is 2. So these numbers are considered the perfect cubes. So if you have 64, we know that that's going to be 4. So we're going to split it into what's a perfect cube and what is not. In this case, 64 is a perfect cube, and the answer is just going to be 4. So we're not going to need that second part. But 512, that's also a perfect cube, and you can check your calculator for that. 512, nothing needed here. Cube root of 512 is 8. So that's all we're going to use there. And then for cube root of 16a cubed, a perfect cube that goes into 16 is 8. Leftover is 2. Make sure you include the index on both of them. And 3 goes into 3 nicely, so I'm going to leave all of those inside of there. And to simplify it, cube root of 8 is 2. 3 divided by 3 is a to the first. And cube root of 2 would be your final answer. Anything with an odd index, we do not have to worry about absolute values. Lots of different rules, so please practice these problems. Okay, cube root of 729. We want to split into 2. Find the cube root of 729, and then we'll split the variable. As you probably already noticed, 725 is in our perfect cube list, so that's going to go in the left side. A to the second does not go evenly, so we have to put those in the right side of the radical. B cubed goes in evenly, and up to 6 of them go into nicely on the first one, and we have 2 left over. Okay, so let's go ahead and solve. 729, cube root of that is 9. Cube root of b cubed is just what's left over. You just take 3 divided by 3. 6 divided by 3 is going to give you the next part. And then the cube root of a squared, c squared. You do not have to do anything with that side. Okay, and then let's go ahead and split up this one as well. What's a perfect cube? What is not a perfect cube? 8 is in the list. It's a perfect cube. 7, I don't think so. We don't need all of them, or we can't use all of them, but up to 6 of them we can put inside of that first radical. There's 1 left over to give us a total of 7. Now to solve, cube root of 8 is 2, and cube root of something to the 6th You're just going to divide divide the exponent and the index to give 2, and then you have the cube root of x plus 2. That's going to be your final answer. Again, none of these need any absolute value signs because it's an odd index. Okay, the next 8 problems I want you to practice and have them ready for class tomorrow. Have them ready to go. I want you to answer them, no blanks. And then the next slide, we're going to do more problems. This is more of a combo of multiplying and simplifying expressions. So before they were all together into one, now they're apart and we're going to pull them together. Okay? So on this first one, we're going to multiply 12 times 4 to get 48 and then see if it can break down. 48 is not a perfect cube. So we're going to split it into something that is, which is 16 and 3. So now I can say, well, I didn't mean that. So 8 and 6. 8's a perfect cube, so we can say 2 cube root of 6 for the final answer. And again, this is called simplified radical form. They are apart, and then you can put them together and then do simplified radical form for the rest. Okay, on this one, we're going to multiply everything together. Now we're dealing with square roots. If you multiply it, you get 90x to the 5th. So what's a perfect square and what is not a perfect square? Well, 9 is a perfect square. 10 would be what's left over. 4 of them would factor nicely, or I'm sorry, would are a perfect radical, perfect square, and the x all by itself is not going to work. So then you have 3x squared, square root of 10x. Final answer, because anything squared, if we put a number in for square, we could guarantee it's positive, so we do not need absolute values. Okay, and then the next one, we're going to multiply those together to get 54ab. Now I want you to split it up and solve. The last one, multiply, you get 64 x cubed y cubed. This ends up being a perfect cube all around because 64 is a perfect cube. 3 divided by 3 is just x. 3 divided by 3 is just x. Final answer, no absolute values necessary. Okay, so let's go to the next part, and I want you to practice these. So not only do you have the ones from before, but you also, so you have that one to finish, and then also this slide, work on that and have it ready for tomorrow.